From ContainerDays Hamburg, this video is proudly presented by Dux IT.
This is the topic I'm going to talk today, and thank you for joining. Please bear with me, this is the first time I'm presenting this talk, so I don't exactly remember all slides I put, so I might mix something, but the first one I remember. As Beren already said, I'm Andrii, I'm a principal software engineer in Delivery Hero, and if you would have any questions, you can find me on any of these platforms. Please add me, send me, chat with me after the talk. We will have lunch. And let's get started. I have a small question to audience. Can you tell me who of you is on call? Raise your hand. Wow, not that much people. Okay. This interesting because in Delivery Hero we operate in 70 plus countries, and as you can see we operate in a lot of time zones, and this means if you don't call, you don't call 24/7. I can say this is a nightmare of on call because you could be woke up any time in the night, early morning, and this is complicated. And to those who is on call, how you usually get paged actually? You can scream from your place. Come again? Yeah, this is one, but I was more about, it could be automated alerts triggering Obsgenie, or it could be manual escalation also triggering Obsgenie from our local teams. This is two main ways to escalate something to our on-call teams in Delivery Hero. And if we talk about automated business and tech alerts, it's very simple. Some deviation in your metric, it triggers alert, it sends you some, you have a lot of options here. You can query, you can open Grafana with all this information, you can open some dashboard, and what is more important, you can, you have run book. So you click and you have exact instruction what you should do to fix the issue. This is amazing. If you have such thing, you are blessed in on-call. You almost don't need to do anything, just follow instruction. But unfortunately, very often we have manual escalations, and when you receive an email from the local team when they state something doesn't work with your system. And in this case, this example of rider application, because I work in logistics, we are doing rider application, everything related, delivering stuff from one place to another one. So it states, rider application in this country is loading too slow and impacting delays and rider experience. So what does it tell us? Almost nothing. Something doesn't work. So usually we put attention on some keywords, so something wrong with rider application. Then we start to look to description, and also sometimes, since it's like people behind this email, they may send you something absolutely confusing, and you need to read it, you need to understand, and there are also some keywords. So riders can start shifts, rider can't make orders pick up and drop off, they have some problems, and this takes too much time. Also, it can have some steps to reproduce your problem. And here, keyword is application is responding slow. So what would we do in this case? From backend perspective, we go and check metrics. Meanwhile, we are asking the team who reported the problem about more details and trying to understand what is going on. And and we're asking which platform affected, maybe they have some specific version which affected. So we're trying to collect more information because for us it's important. And we're checking our metric, and you can see our metric about P99 looks good. In Delivery Hero, if we have P99 less than 150 milliseconds, we consider it perfect. So our service works. We don't see any spikes, we don't see any deviations. Everything is good. And yeah, all business metrics good. No drops, no spikes, no deviations. Then we need to investigate more. That's why we ask local team about more information, what is going on. Maybe they can nail down us to some problematic version of application riders have. And sometimes we ask ourselves, is this false positive? Sometimes it may happen because we all humans, we all may overcare, let's say, and trigger incident where there is no incident. Maybe only a couple of riders were affected. Where on our scale we operate with 100,000 of riders. But the problem that before we can call it false positive, we need to understand how, in general, infrastructure in the world looks like. And we have a couple of components. We have mobile application here. We have internet service provider on the local. We have Cloudflare. And we have our cloud. Inside the cloud, we have load balancer. We have Kubernetes cluster. Inside Kubernetes cluster, we have ingress. And we have our API gateway. And only then we have pods. So far, checking our business attack metrics, we check it only this part. Very small part of entire journey of our API request. So again, we read the description, what Tim already shared with us. And also it states only rider app is impacted when other applications working fine. So riders have, I don't know, Telegram, some messengers, and they work. Only our application doesn't work. So again, this could lead us to some problems with the new release. So the next, what we can check, did we do a new release of our application, which can be with some errors. And we check it, no. There is no new release, this is old release, everything should work fine. Then we get reply from our local team, and this states riders on all platforms, iOS and Android, are affected, which means engineers do mistakes, but they can do mistakes in two different platforms, which two different repositories. So problem on the backend. So we check it on, maybe not on the backend, but somewhere between the mobile phone and our pods. So what we do, we check metrics of our next component we have in this chain. Here is Conch, our API gateway. We check, and we also don't see any deviations, any spikes, which could explain this slowness of application. Then we check the next component we have in our chain. This is our ingress, Nginx. And situation is completely the same. There is no problems. Everything works fine. Then we also check our load balancer and metrics as well, fine. And here we have only two components left, and whom to blame, actually. So the problem with Cloudflare, it doesn't provide us information about performance. It gives vast amount of information, caching, status codes, content types, and so on and so forth. But if you ask Cloudflare how your requests process it, how long does it take, what is P99, it doesn't give you this information. So what to do? We tend to not blame Cloudflare. It's a global service. If it has outage, you can go to status page. You can check if something works or not with Cloudflare. And you can check if something out. Many people will be writing in Twitter or whatever about Cloudflare is down. So the problem with ISP. But this is another nightmare of on call, how to monitor and test something which you don't have control and which is even on another continent. And yeah, this is what I said. This is a nightmare. You can test it, you understand there is a problem, but you can't do anything. So in this case, we got lucky because we have Firebase. This is free service from Google for push notifications for some real-time databases, and also it has metrics about performance. And as you can see, it clearly shows something doesn't work. Increase like 10,000%. Crazy, right? So it's good, but also problem of Firebase. Firebase is free. And what does it mean? It doesn't provide you a lot of opportunities how you can use it. If you ever used Firebase, maybe raise the hand who used Firebase in their life. Very few people, but yeah, you maybe understand because you can't, for example, filter this performance 2 days before. It will show you some very, very generic metrics. You also can't define any alerts based on this deviation. What you can do, you can export this data to BigQuery, and based on BigQuery, you can define some alerts. And you can't imagine how this is expensive. So we can't use Firebase for automated alerts in this case. If we receive such alert from local team, we can go and we can check and maybe find something, but it's, you need to involve human in this. So this is how our metric time to backend was born. And this metric represents time from the moment request was initialized in the Rider mobile application till the moment this request was received on the backend. Eventually, it means how long does it take to go through mobile APIs, through ESP network, through Cloudflare, AWS network, and reach our service. And this is how it is. So this is time to backend. We created this metric, and we started to monitor our system. And how we created this metric, it's super simple. So every request we send from the mobile, we add specific header, which specifies the timestamp when it was initialized. When we receive it on the backend, we just calculate this offset, and this is our time to backend in milliseconds. So we can log it, we can send the metric to Grafana, and then we can define the alert. And there are many open questions which we were discussing before introducing this metric because it was a lot of concerns. And because we are working with end devices and riders can do whatever they want with these devices, it's dangerous because they can change time, they can change time zone, and this can affect. But what we understood at the end, even if rider changing this and they do this to fraud our system, it's very, very small amount of cases. As I mentioned, we have hundreds of thousands active riders. And if few of them or even hundreds of them modifying and affecting our metrics, it doesn't much change anything for us on the end. And this is how it looked like. So you can see this is distribution from the 0 milliseconds to up to 50, and this shows different days. So you see during the day we have bigger load, we have more metrics, and we have some clear patterns where requests, how fast requests are processed. And this, for example, where we see deviation in our metric. So something doesn't work, and our metric clearly moved to up to 4 seconds. In this case, we have alerts. This alert will be fired, and team will receive, and team will be work on this alert. this is another representation, and this is very interesting because what we figured out that in general the time to the backend is 2 seconds. This is very fun because also if you try to optimize your application, you usually try to optimize some processes, memory allocation, and you can win maybe a few milliseconds. But you see, this few milliseconds doesn't matter because you have 2 seconds just to reach your backend from the mobile. And this is what good in this, because we move it from the, as I mentioned from the beginning, we have 2 types of escalation in our system. The first one is this automated business and tech metrics, and second one, the manual one. So we move it from the manual one to automated. So we have runbook. So any engineer who received this alert, they can open runbook and validate. If something doesn't work, they can use this metric we have and clearly see, okay. Also, it's not visible on the chart, but we can filter by different ISPs. So you can clearly nail down to some ISPs, finding which one doesn't work, because we also collect this information. Okay, did we create a masterpiece? And I can say, like, yes. Back 4 years ago when we created this metric, it was helping a lot, because before, as I mentioned, we had to go a lot of business and tech metrics we have in our system on the backend to validate that the service works. And you need to understand, because we have microservice architecture. We have some gateways which aggregate requests from different services, and you need to check a lot of metrics to understand if everything is in order or not. And I can say this metric helped a lot, because we had one metric, you go, okay, if your application is slow, you just can check if it's really slow or not. And yeah, talking again about 2 seconds, these 2 seconds only in one direction. And your request needs response, which will take another 2 seconds. So eventually it's 4 seconds wait time for your end customer at the end. And as I said, if you do micro optimizations like milliseconds, it won't be visible with all of these network processing. Yeah. This is one of my favorite slides. And the biggest question which we had at some point, why we built this metric, why we can't use just observability, because we have traces, we have spans, we should see all of this. The problem that observability in backend and in mobile is a bit different, because we also track different things. On the backend, for us important some service healthiness in general. How many requests we processed, which endpoints were processing these requests, P99. For mobile, these metrics doesn't matter. For mobile, more crucial is the end user and the end user behavior and how application works for the end user. So they have this conception of the sessions and they monitor what happened for the particular user on the mobile, which for backend creates a huge cardinality, because this is vast amount of metrics about the rendering screen, about the different buttons displayed, rendered. So we don't need this on backend. So it was super complicated to know to match all of this between backend and mobile. That's why we decided to introduce the metric. Right now we're trying to play with Sentry, which allows us to ingest some spans and traces from mobile and connect it to the backend. So we will have this more holistic overview, our burn graph about how application performs. But this is in the future. So far we still use this metric we created 4 years ago. And the question how to improve this 2 seconds. What can we do? The problem, because we are using TCP protocol, and it's very slow. And if you use UDP, yes, you will lose some data, but it's faster, much faster. And we do some experiments in Delivery Hero about HTTP3. And guys achieved 200 milliseconds win on handshake. And again, the problem, you still have 4 seconds. So, yeah, this is comparison, and you can see the protocols is a bit different. Also, what you need to understand, all your components on this chain should support HTTP3, and if one of them doesn't support, it doesn't work as well. What else? As a conclusion, before optimizing your application performance, make sure you need it and you will gain anything without wasting a lot of engineering time. Make sure it will bring value. And make sure you have full picture of how your application reachable actually. And optimize only when necessary for a defined value and with a complete understanding. Anything else is a gamble with complexity. And yeah, this talk was inspired by a talk from Jonathan Amsterdam on GopherCon 1 year ago. And he was presenting a new HTTP router implemented in Golang. And he was reflecting a lot about pressure from community to keep this performance on the high level, but at the end he said, but you use HTTP and you use JSON. What type of performance are you talking about? So yeah, and I want to add on top of this, you're also using all of this infrastructure, which very slow. And yeah, just sponsor post. We are hiring. And if you want with me solve these complex problems with routing of your request to your application, please join me, don't hesitate. And again, if you have any questions, we have lunch, you can approach me during the lunch and ask whatever you want. That's all. Thank you.
A lot of people are really interested in, where can I get this nice t-shirt?
I did it. You can order from me.
So side business, new side business, awesome, good to know. So you're still around also tomorrow, maybe? So you can ping him for t-shirts. What is the issue of that 2-second request?
What is the issue?
So what was the issue of that 2-second request?
Because it's not only 2 seconds, it's 4 seconds at the end. And when, for example, your end user clicks on the application, it takes 4 seconds to finalize request. For them, it looks very slow because they get used to this. For example, I don't know, Twitter, Telegram, when they have response very fast. And this for them looks very slow, like something doesn't work. They're clicking multiple times, they're trying to refresh application. Too slow for people.
Thank you. Isn't it the same as time to first byte, like TTFB?
I can't answer this clearly because this depends where you cache this first byte, on your application and from where, because in some infrastructure, when your request goes, this request dropped and recreated by another service. It's not that connection from your application till the end. There is no like one connection. This is chain of different connections.
Thank you. Next one is a bit longer. Do you track available bad connectivity bandwidth on mobile devices and can lay such effects as metrics next to TDB metrics? Bad network in dense build areas, for example?
Yes, we do. But I can't answer this because I'm not mobile engineer. I'm not very familiar with this. Sorry.
Sounds fair. Still some room for discussion later on.
Yes.
Did you consider switching away from Cloudflare?
Actually, the Cloudflare was solution we migrated a couple of years ago from another one, and I would say we're more satisfied with previous one right now.
Okay.
So no.
That's the short version. Good. Let's give another 3 seconds for incoming questions, but I don't see anyone typing anyhow. So then, Andrii, thank you so much for your talk.
Thank you.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.